Hey guys, Mr. Ray here with our last and final unit in calculus. So this is kind of a wrap-up unit. As you've seen in most math courses or units, we always end up with some applications. And we already did applications for vectors. So we're going to look a little bit deeper. I mean, we already looked at curve sketching. That is an application on its own. But we're going to look at things like optimization and just a couple of topics that are of some interest. We'll actually kind of revisit some problems that you did in earlier grades, like maybe with quadratics in grade 10, and see the solution from a calculus derivative perspective. So the first lesson, we're actually going to do 3 lessons. So this is the way it's going to work. We'll do just 2 lessons this week, Monday and Wednesday. There won't be any assignment due this coming weekend. And then I'll just give the last lesson on like a week from now, the second Monday. So a week after this lesson has been put out, lesson 3 will be on Google Classroom. And then I think what I'll do is I'll just release, put the lesson out there on, say, Tuesday, and have that due. Well, I'll let everyone have the whole week to do it. So for Sunday night, I'll do something with a bonus, but it won't be Friday at 8 p.m. It might be something like Thursday or something like that. I'll let you guys know when we do that third lesson as to how the assignment's going to work, but it'll be something along that line. Okay, so anyways, 3 more lessons. This is the first of the 3. So what we're looking at here, the maximum and minimum on an interval. So we're going to look at different kinds of functions. Most of these I think all of these will be polynomial or rational. And we want to find the lowest or highest values on an interval. Okay, so you might think, well, isn't that just the maximum and minimum points? Well, since this is on an interval, it's not what we would say is the global, the highest or lowest values that this function ever gets. It's for a specified range or domain of the x values. So I could say, now I might have a function. I'll just graph a function here. Maybe the function looks something like this, right? And I'm only looking, for this interval here of x values. So within, say, these values here. Okay, and I want to find the lowest or the highest value of this function from this x value to this x value. So the first thing we're going to do is do what we've already looked at. Find the critical points, the local min or max, extrema. So if I was to look for the extrema on this function, I would find, 1 here. I'd find 1 here. I'd find another 1 here. Okay, now the first thing I would say, well, this one doesn't matter because it's not within the interval that I've specified. So this one gets eliminated right away. But then you might think, well, we could find out which is the higher point between these two, and that would be the maximum. But that's not true because this value here at the beginning of the interval actually is the local max. Okay, so the thing we have to add to this this procedure is first we find the critical points, and then we also check the end of the interval points, and then we actually evaluate what those values of x are and find the lowest and the highest. Okay, so that's what this lesson's all about. So just a couple of definitions here. Max or min values of a function at interval are also called extreme values or absolute extrema. So absolute means the highest of the highs. It doesn't actually have to be doesn't have to be a critical point. It could be an end of the interval point, like we saw up here. Okay, so the maximum value of a function that has a derivative at all points in an interval occurs at a peak where the first derivative is equal to 0, that gives you the critical points, or at an endpoint of the interval. So it could be at one of these values, it could be any number of values within the interval, but you also test at A and B to see what those values are. And the same thing applies for minimum. So this is basically same definition, just replaced max and min. Okay. So here's the little process. We already talked about it. First thing we do is we find the first derivative of the function. Okay. We set it equal to 0 and find all the possible values of x where that's true. Now, one thing, it doesn't really say in this process. If the value of x is outside the interval, we can safely ignore it and just use the ones that are between a and b in this case. And then we also evaluate the function at the two endpoints. And at points, so we take the points we found in step 1, we find basically the y value for those critical points. We also find the y values for the points A and B, and we compare all these. And if we were looking for the largest, we take the maximum of all these values. Looking for the minimum, we take the lowest. Okay, so let's try this out. It's a pretty quick lesson, actually, so hopefully it makes sense to you. Okay, so find the extreme values for this function f of x cubic on the interval between x's between -1 and 5. You notice it includes those two values. The intervals always will include those. Okay, so the first thing we do, find the first derivative. This is polynomial, so it's fairly straightforward. That's equal to -6x squared plus 18x. And now to find the critical points, we set that equal to 0. And we're going to solve. So I'm going to factor out -6x. And I get x plus 3. And that tells me critical points will be at x equals 0 or x equals 3. Okay? Stuff we've already done before. So now the points I'm going to look at, and you notice these 2 points, 0 and 3, they're actually in between, they're actually on the interval we're interested in. So I don't have to, I'm not throwing out any of these. So what I'm going to do, I just put, usually go, high or lowest to highest. So I'm going to find the value, basically the y value or f at each of these values. So the first value I want to test at -1. Then I'm going to test at 0. I'm going to test at 3. I'm going to test at 5. So I just kind of put these all out here. I usually put them in a vertical thing so you can compare them quicker. So I'm basically plugging in these two x values and these two x values for the interval, and let's see what we get. So when you plug these in, we get 15, 4, 31, and -21. Okay, and it's asking for the extreme values, so that includes both maximum and minimum. So what I do now, what's the highest of these? Well, that's going to be our max, and the -21 will be our min. So one of them, the local or the extreme maximum value is actually one of the critical points, but the extreme minimum value is actually one of the endpoints at 5. Okay, so therefore the max value of f of x for, and I'll put the interval here, -1 to 5, is 31, and that's the point right here. And then the min value of f of x, I guess I could repeat this, is -21, and that comes from this point. Okay, you don't have to put the x coordinates. It might ask you in the question, but for this, the way this is worded, you're just looking for this answer. Okay, so hopefully that was painless, I hope. All right, now here's a word problem, but it's really not that difficult to read through. The amount of current in amps is in an electrical system is given by the function c of t, so that's the amperage based on the time in seconds. You get a cubic here, where t is the time in seconds, and we're interested in the the time between 0 and 5 seconds. So the first 5 seconds it's turned on. We want to know, well, actually you don't know what we want to know yet. Determine the times at which the current is at its maximum and minimum, and determine the amount of current in the systems at those times. Okay, so in this case they're actually asking for both. They're looking for the time the max happens and how much current it was, and the time that the min happens and how much current that was. Okay, so we're going to do the same thing. First we find the first derivative of the current function. So again, it's a polynomial, so negative 3t squared plus 2t plus 21. Okay. Set that equal to 0 to find the critical points, which could be maxes and mins. Can't really factor the 3 out, so this is I could just change the sign here to make the factoring easier. I always like to do this. And then this becomes complex trinomial factoring, and this factors to 3t plus 7, t minus 3. And from that, we know that t is either equal to negative 7/3 or 3. Okay, so these are your critical points. And now we also have to test for 0 and 5. So I'll do my... now, the first thing I noticed, well, we didn't talked about last time, we're only looking for that interval, 0 to 5 seconds. That critical value is outside that interval, so we can ignore that because we're not looking at that time, plus it's negative time anyways. So I'm looking at 0, I'm looking at 5, and I'm looking at 3. So I want to find the actual amperage, the current at C0, C3, and C5. So I'm not plugging it back into the derivative now, I'm plugging it back into the original current equation. And when I get that, I get a 0 here, I get a 45 at 3 seconds, and a 5 at 5 seconds. So we want to know the lowest and the highest. Well, this looks like that looks like the min right there, and this looks like the max. This is somewhere in between, so it's not really that important. Therefore, the max current is 45, and so use our units, amp, capital A for amps, and this is at 3 seconds. I'm saying it this time because it asked for when did these max and mins happen, and the min current is 0 amps at 0 seconds. Okay, and that's pretty quick. Let's do last question, last example. This is a rational function, so the only thing that makes this more difficult is finding the derivative, I think. So this is the amount of light intensity. It's given by a function called L of t, so basically light intensity at a time t in seconds. And we want to know the minimum intensity when the light was at its lowest level between 0 and 14 seconds. So first thing we do the derivative of the light intensity, and I would definitely do, for these type of applications, definitely do the quotient rule, because you're only going to get one term with the quotient rule, whereas if you do product rule, changing this to t plus 2 to the negative 1, you're going to end up with two terms. You're going to have to combine them anyways. So this definitely, so I'm going to take the derivative of the top function, that's a 2t plus 2, times the bottom function, t plus 2. We subtract the derivative of the bottom, which is 1, times the top function, t squared plus 2t plus 16, and then the bottom function squared. And I'll set this to 0 now, because I'm going to, once I simplify this, I'll just cut to the chase here. That works out to t squared plus 4t plus 12 over t plus 2 squared. Again, this is why I'm saying quotient rule is better, because we have to combine it into one term to solve for 0, because basically this means that the numerator has to be 0. T squared plus 4t plus 12. Factor that. Factors nicely. If it didn't factor nicely, of course you'd use quadratic formula. We get t plus 6, t minus 2. So therefore t is equal to negative 6 or 2. Okay, and again, we're looking for the interval 0 seconds to 14 seconds. So if you wanted to be official, you could say not in interval. I don't expect you to do that, but you definitely have to cross it off that you've actually calculated that, but it's not being considered for some reason. Okay, so we want to find the light intensity at 2 seconds from this critical point, and we also want to find it at 0 and 14 seconds. So we're going to do L at 0, L at 2, and L at 14. So plug it into the original equation. We're going to get 8. I'm not even sure what the units are here. Just call it units, I guess. At 2 seconds, the light intensity is 6, and at 14 seconds, the light intensity is 15. So we're looking for the minimal only. So lowest of these three is the 6. So therefore, the minimal amount of light intensity is 6, and I'll just put units, which occurs at 2 seconds. And that's it. Okay, so it's pretty straightforward. Find the critical points using first derivative, and then also we're gonna find the actual value of the function of those critical points, and also find the value of the function at the endpoints of the interval, and compare the values to find highest and lowest based on what the question was. Okay, a few questions to try out for homework, so give those a try, and I will of course have my office hours on Tuesday and Thursday this week, so if you need any help on this, please come and show up. I'm not getting all that many people. That's either good or bad news. I'm not sure which. But the next lesson will be another lesson on a new perspective on applications of derivatives. That'll be Wednesday this week, and then the final lesson will be next Monday, and I'll put the assignment for this unit out on Tuesday. Okay. All right, guys. Have a great week.